Section 4.4 is on risks and odds. And we first start off with absolute risk reduction. This is where for a prospective study, an example of the results would be something like this table here. So this is a generalized table summarizing results of a prospective study. We have, a disease or no disease, a treatment, and a placebo. And then we have those different values here labeled as A, B, C, D in order, respectively. When comparing two probabilities or rates, though, the absolute risk reduction is simply the absolute value of the following difference. The absolute value of the probability of event occurring in treatment group minus the probability of the event occurring in the control group, or known as the placebo group. If the data are in the generalized format, such as this, we can rewrite this as the absolute value of A divided by A plus B minus C divided by C plus D. Then, as an example of this, based upon the table that we have done here, we need to find the absolute risk reduction, which can be used to measure the effectiveness of the Salk vaccine, which was used as a treatment to polio. But the absolute risk reduction takes the absolute value of 33 divided by the total of 200,745 minus 115 divided by the total of 201,229. Tossing that into a calculator, we get an answer of 0.000407. So 0.0407% fewer events of polio for subjects treated with the Salk vaccine, according to this. The relative risk, we can denote this by the probability sub t as the proportion or incidence rate of some characteristic in the treatment group, and p sub c as the proportion or incidence rate of some characteristic in a control group. And for the prospective study, the relative risk, or risk ratio, or just denoted as RR, of a characteristic is the ratio p sub t divided by p sub c. Or, using the formulas that we saw in this table, we can write that as A divided by A plus B divided by C divided by C plus D. So the relative risk of 1 shows that the treatment and control groups have the same risk approximately. A relative risk greater than 1 shows greater risk for the treatment group, and a relative risk less than 1 shows lesser risk for the treatment group. So for example, if we take, based upon the Salk vaccine that we were looking at in example 1, the probability sub t is going to be 0.00164, and p sub c will be 0.00571. The risk reduction then would divide those two numbers. So 0.000164 divided by 0.000571. That's about 0.287. So the polio rate with the Salk vaccine is 0.287 of the polio rate of the placebo. For the number needed to treat, this would be the number of subjects that must be treated to prevent even one event, such as a disease or an adverse reaction, and then we would then round up to the next larger whole number. So for this, the number needed to treat is 1 divided by the absolute risk reduction, or 1 over the absolute value of A divided by A plus B minus C divided by C plus D. So for example, using the polio data from the table below, we want to find the number needed to treat and interpret the result. So from example 1, find the absolute risk being 0.000407. So 1 divided by 0.000407 is 2,457.002, which we would then round up to 2,458. So you need to treat 2,458 subjects to prevent one case of polio with this Salk vaccine. The odds are where we want to the actual odds against event A occurring of the probability of A complement divided by probability of A, which we could then write as a different ratio format as A colon B, where A and B are integers, and it reduces, and we can reduce it using the largest common factor. And this can be read as A to B. The actual odds in favor of event A occurring are probability of A divided by probability of A complement, written as B to A. This is the reciprocal of the odds against the event. And in gambling situations, they use a payoff odds, which would actually give a different number than these two calculations. And this describes the profit relative to the amount of the bet instead. As another example here, if we consider this table down here, based on results from the safety of newborn early discharge by Liu, Clemens, Shea, Davis, and Novak, from the Journal of the American Medical Association, volume 278, number 4. And we want for the babies discharged early, find the probability of being rehospitalized within a week. So the probability of rehospitalization, 457, divided by 3,656. That makes 1/8. For the those babies discharged early, find the odds in favor of being rehospitalized early. So probability of not being rehospitalized, if this is 1/8 for rehospitalization, not rehospitalized is 7/8. So the odds then will be A divided by B, so 1/8 divided by 7/8 to be 1/7. And we can write that in odd form as 1/7. The odds ratio for the retrospective or prospective study, the odds ratio, or OR, or relative odds, evaluates the ratio of the odds in favor of the treatment group to the odds in favor of the control group. And as a nice little formula, that's AD divided by BC. An example of that will be based upon the data down here. We want the odds ratio for rehospitalization. So for odds early, that's 1/7. For odds late, that's 1/11. 1/7 divided by 1/11, that's 11/7, or as a decimal, 1.571 about. The relative risk is only calculated for a prospective study, and the odds ratio is for either a prospective study or a retrospective study. Thank you.